Welcome dear students, we are on the CEC Gurukul lecture. We are in the physics lecture series, and in this series we are discussing the electronic circuits and what are the components we use in the electronic circuits. We are discussing one by one. Now in today's lecture we discuss one of the most important component which used in the electronic circuit, that is the motor. So in today's lecture we discuss the motors. Basically we discuss the electric motors. So on the screen you can see that this is a one type of motor that is rotating, and here we are having a south or north pole, and in between that a motor is rotating. So today's lecture is the motor. Then what is this word come from the motor? Why, what is this motor? This motor word refers to the power unit that generates the motion. As you see here that this is generating a motion. Here as we giving the power, then it will give a motion. So the motor refers to any power unit that generates the motion, and that is the prime mover. While electric motor, as we discussing the electric motors, then what is this electric motor? Then this electric motor is a prime mover, but by using the electricity. Mean these electric motors moves or rotate when we apply the electricity to these motors. So that's why it is called the electric motors. So electric motor, what is the electric motor? That is a electronic device that converts the electrical energy to the mechanical energy when we apply the electromagnetic phenomena. Means when we are giving the electric current, then it converts the electrical energy to the mechanical energy. As you see on the screen that here we are just giving the electrical energy, then it converts, then it moves, and the output is in the form of the mechanical energy. So the various types of electric motors, and they are different, they work in the different ways, and in which the conductors and the fields are arranged, and also in the control that can be exercised over the mechanical output, torque, speed and position. It means we generate or we prepare a motor according to the requirement, according to its application, according to its mechanical output, like in the form of the torque, speed and the position. And we apply the electric field to the motors, and we just arrange the conductors and the field so that it can be controlled and the output in a desired form. So the various type of electric motors differs in the way in which the conductors and the fields are arranged in such a manner or controlled in such a manner so that the mechanical output in the form of torque, speeds and the position can be generated. So how these electric motors can be classified? These electric motors are classified into three ways based upon generating its torque to lift the load and move objects, and various other parameters have to keep in mind to classify the motors. So an electric motors, that is a machine that converts the electric energy into the mechanical energy, and it is used for generating the torque to lift the load, move the objects, and the various other mechanical works can be done through these motors. So the motor, on the basis of that, motors are classified into three ways. Number one is the AC motors, number two is the DC motors, and number three is the special motors. We will discuss one by one, and we will discuss further its classification. Now here on the screen we are seeing that there is a type of motor. Motors are of two types here we define basically. One is the DC motor and AC motors. Again the DC motors are classified into two ways. One is the brushless and second is the brushed. These brushed again classified as the series, shunt, compound and permanent magnet. So these are a further classification of the brushed motors. On the right hand side we have the AC motors that are classified into the two form. One is the synchronous and other is the asynchronous, that is also called the induction. and this asynchronous further divided into two parts, that is a single phase and the three phase. So we will discuss one by one all the motors. So again we can see that the AC motors, it means that is a alternate current motors, and these AC electric motors that converts the AC electric energy into the mechanical energy. So these are the AC motors. These electric motors are powered using the single phase or the three phase alternating current. When we supply the single phase current or three phase current, on the basis of that it is classified. The basic working principle of AC motor is the rotating magnetic field, that is also called the RMF, that is a rotating magnetic field generated by a stator winding when an alternating current is passed through it. Then its rotor, which is having its own magnetic field, follows the RMF, that is the rotating magnetic field, and starts rotation. When it rotates, then it converts the electric energy into the mechanical energy. Now the AC motors further divided or the further classified into two types. First is the synchronous motor and second is the asynchronous or the induction motor. On the screen you are seeing, and most commonly you have seen these motor in your houses and some industry and the offices. So these are general use in the daily life. So here we discuss the AC motors into two parts, synchronous and asynchronous or the induction motor. Now the synchronous again classified into the two types, excited synchronous motors and the unexcited synchronous motors. Excited synchronous motor work in the single phase as well as the three phase synchronous motor, while the unexcited synchronous motors are classified into two types. That are two types, like one is a reluctance motor and other is the hysteresis motor. We discuss one by one. So first we discuss the what is the synchronous motor. As the name suggests, synchronous. Synchronous means is having the constant speed. So as its name suggests that the AC motors has a constant speed, that's why it is called a synchronous speed, that only depends upon the frequency of the supply current. On the basis of that we just keep the speed constant, and that's why it is a synchronous motor. The speed of such electric motors only varies with the variation in the supply of the frequency and remains constant upon the varying load. It means we have just keeping the speed constant, and it is used for the constant speed application and the precision control. So these are the synchronous motors where we are having a constant speed or synchronous speed we are having. The synchronous motor has the same stator design as asynchronous motor, but it generates a rotating magnetic field when supplied with the input alternating current. While the rotor design may vary, it uses the separate DC excitation to generate its own magnetic field. So synchronous motor has the same stator design and synchronous motor, and it generates the rotating magnetic field when we apply the current to it. So the rotor design for this rotation is use separate excitation to generate its own magnetic field. So we use the second another DC excitation for this. So the further synchronous motor divided into two, excited synchronous and second is the unexcited synchronous. So excited synchronous is that type of motors which requires the DC excitation. So DC excitation means that the rotor has a separate DC supply to generate its own magnetic flux. Means in the AC motors we have to use the DC excitation so that we can generate the magnetic field, and that will produce the magnetic flux. This flux reacts with the revolving flux of the stator to generate the rotation. Now because of this the rotation will takes place. The utilizing wire wound rotor with commutator and brushes assembly to supply current to the rotor's windings. Rotor is there, and by using and the brushes assembly are arranged in a system, and when you supply the current, then this rotor's winding, then it will the magnetic flux generate in it through it. So further it again divided into two parts. First is a single phase synchronous motor, second is the three phase. In the single phase, when we just the motor runs on the single phase AC supply, that is a single phase synchronous, and to be precise it actually uses the two phase, the second phase one being derived from the first phase, and the reason for using the two phases is that a single phase cannot generate a rotating magnetic field, so we require the second phase also. What is the single phase synchronous motor, and the second phase is being derived from the first phase itself, and the such motors can start in either the direction, that is the direction is unidentified, which is why there is an extra starting arrangement used for giving it a direction. So giving a direction, we use the extra arrangement for this. The speed of such a motor only depends on the supply frequency, and they are used in recording instruments, electric wall clocks, and many more. So it works. And another is the three phase synchronous motors. As the name suggests, we use the three phase power supply in this synchronous motor to run. The benefit of the three phase alternating current is that it generates a rotating magnetic field in a stator, while the arrangement of phases decides the direction of the rotation. Previously there was no the direction is unidentified, but here we decide the direction of the rotation, and these motor does not need any special starting mechanism to decide the direction. However, the rotor still needs an extra DC source for excitation as in the single phase, and they are used in the industries for application that requires the constant speed over a range of the loads and require the precise positioning in the robotics. Where we require the constant speed, then we use the three phase synchronous motors, that is a excited synchronous motor. Now next is the unexcited synchronous motor. What is this unexcited synchronous motor? And that does not require the DC excitation. In the excited synchronous motors we require the DC excitation, but here in this unexcited synchronous motor we do not require the DC excitation. This motor does not require any DC excitation. It means rotor does not require separate DC supply for generating the magnetic flux. They utilize the squirrel cage rotors such as the one used in the induction motor. It works as an induction motor, so it uses the squirrel cage rotors to generate the magnetic field. Further it divided into two parts. First is the reluctance motor and second is the hysteresis motor. So in the reluctance motor, a single phase synchronous motor that works on the principle of generating the torque based upon the magnetic reluctance. So there are two types of stator winding. Auxiliary winding is used for starting the motor, and second is the squirrel cage type rotor. There is no winding, so auxiliary winding and no winding, the both the type we use in here, just like an induction motor made for to making it a ferromagnetic material. So for then second is the hysteresis motor. Such type of synchronous motor works on the principle of hysteresis loss or the residual magnetism occurring in the rotor. So how we can calculate it is such electric motors are operated using the single phase as well as the three phase AC supply. We can use this motor in the single phase as well as in the three phase. In the single phase hysteresis motor, there is an auxiliary winding and beside the main winding as in the reluctance motor. The rotor, which is cylindrical shape, is made of the ferromagnetic material with high magnetic retentivity or hysteresis loss, such as hardened steels we use here. The rotor is supported by the non-magnetic shaft. In this type of motor, in this type of motor is same as that of the induction motor starts. So stator's rotating magnetic field induces eddy current in the rotor, and that eddy current generates the torque, and along with the hysteresis torque due to the high hysteresis loss property of the rotor's material. So due to the eddy current torque, the motor behaves as an induction motor. That's why it is also called the induction motor. That is, motor start as an induction motor because of the eddy current that produce the torque. Once the motor reaches the near synchronous speed, the stator rotating magnetic field pulls the rotor in the synchronous. So the rotor ferromagnetic nature produces the opposite magnetic poles due to the stator's RMF, and it starts behaving as a permanent magnet. And at such a speed, there is no relative motion between the stator and rotor, and so there is no induction in between there. Now, therefore, there is a no eddy current or the eddy current torque. No is not present. The torque produced by the motor in the synchronous speed is due to the hysteresis, which is why it is named as the hysteresis motor. Here we don't require the eddy, but here it require the here it is a work on the hysteresis laws. What is the main advantages of hysteresis motor is that it is a brushless motor, and there is no windings inside the rotor, and it does not generate any noise, and its operation quiet, and it operates in the quiet manner. So it will not produce any noise. What are the disadvantages of this type of motor? It generates very low torque. Then we know when we require the high torque, then we cannot use this type of motors. If the low torque increases a certain limit, then its speed drops, turns no longer operates as a synchronous motor. So it means speed it will change, it will not work on the constant speed. So sometimes it disturbs if the load torque increases a certain limit. So and it has less efficiency, it is only available in the small sizes. Moreover, it is used in record players that requires a constant speed for recording of a playback features. Also, electric clock requires a constant speed, etc. These are the some of the application. Now, another type of motor is the asynchronous motor. Up to now we discussed the synchronous, now we discuss the asynchronous motor. Why it is called asynchronous? Because it never runs at a synchronous speed. Means speed is not constant in this type of motors. So this type of AC motor that never runs at a synchronous speed, and its rotor speed is always less than that of the synchronous speed, and it does not require the separate rotor excitation. So synchronous motor are classified into two types. One is the induction motor and second is the commutator motor. So what is the induction motor? Induction motor is one type of the AC synchronous motor that works on the principle of electromagnetic induction between the stator and the rotor. The revolving magnetic field induces a current in the rotor due to the electromagnetic induction, which produces a torque in the rotor. It means this motor produces a torque because of the electromagnetic induction, and it is mostly used in electric motors, this type of electric motor in the industries. And again it is divided into two types based upon the construction of its rotor. One is the squirrel cage induction motor that rotor, such as the induction motor, resembles as a squirrel cage, and it is made from the copper bar connected at both the ends using the conductive rings to make a closed loop circuit. Here we use the copper bars, and we produce a cage type of structure in it, and it makes a closed loop circuit. There is no electric connection to the rotor. So the stators, in this type of the stators varying magnetic field induces a current in the rotor's bar, and the induced current generates its own magnetic field in the rotor, and which interact with the stator's revolving magnetic field, and it tries to eliminate it by revolving it in the same direction. So it is a very simple design, inexpensive, and it is a more reliable since there is a no electric connection or commutator, and the brush assembly is there, and it requires the less maintenance as compared to the synchronous. And the next type of is the slip ring or the wound rotor and induction motor. Here the slip ring or the wound rotor induction motors is another type of the induction motor, where the rotor is made of the winding that is connected with the slip rings. These slip rings are used to connect the windings to the external resistors for controlling the rotor current, and hence allowing the control of the speed or the torque characteristics. So here we use the slip rings in this type of induction motor, and it is having the same operation principle as the squirrel cage induction motor, except for the induced current in the rotor can be controlled using the external resistors, because we are using the resistors here. So external resistance also helps to increase the rotor resistance during the startup of the motor to reduce the high inrush current. So it is increased starting the torque to left high initial loads, and in this slip rings constantly slides with the brushes that requires the costly maintenance. So due to mechanical wear and tear, the construction is so complex, and it is more expensive than that of the squirrel cage motor. Another type of motor is the capacitor starred induction motor. In this type, apart from the resistor, we use the capacitor in the series, and its auxiliary winding to generate the extra torque during the startup. And its name clearly suggests it is a capacitor is only used for starting the motor. So it is disconnected once the motor reaches nearly synchronous speed and using a centrifugal switches. So you see on the screen that this is one type of the capacitor starting induction run motor. So you see auxiliary winding is there, main winding, left hand side a single phase supply is there, and right hand side we are giving the starting capacitor and the configure switches. Thank you very much.